Is Divestri from 3P department. This is my save and assessment of Power BTech on second semester. My subject is electric drives. Through electric drives, I selected a topic on electric drives used in EV systems and in this present generation. Now we'll move on the topic. Electric drives in EVs. Electric drives are the system that controls and in generally we can define that electric drives means they control the systems. They control the speed, torque, and the direction of a. They control the speed, torque, and direction of a system of the vehicle of the motor. In electric drives in EVs means the electric is a system that controls the delivers an electrical energy from the battery and the converting the electrical energy into mechanical motion to move the vehicle. They include the components like through inverters, controllers, and they manage through the inverters and motor controllers. They can manage the speed, torque, and direction of the EVs, and it gives a more efficient performance also. Electric motors in EVs provide instant torque to get the smooth acceleration and improve the responses and compared to the conventional engines. The drive system supports the regenerative braking, which captures the energy during deceleration and it turns into the battery. Electric drives help simply to determine often eliminating the need of multi-speed transmissions and reduce the maintaining cost also. Importance of electric drives means high efficiency gives the better range and energy usage. The instant torque gives a strong performance. The zero emissions give the cleaner environment. Low maintenance gives a low cost, and the quiet operation gives a better comfort. And regenerative braking gives the reduces energy. Precise control gives a better driving dynamics and instant quiet performance. Sustainable energy usage gives a support future power grids. Types of electric drives used in EVs. In EVs, in electrical vehicles also we use electric drives like motors. There are some of the electric drives used in EVs. Some of the electric drives we will discuss now. Brushless DC motor drive, we will call as BLDC, and permanent magnet synchronous motor drive, AC induction AC induction motor drive, switcher reluctance motor drive. We will see deeply about these electric drives. Brushless DC motor drive. This is the brushless DC motor drive. The diagram. These motors are brush free and use electro in the word only. The brushless DC motor drive is there the meaning in the word. Like brushless means without brush only the electric motor works. Like these motors are brush free and use electric communication, giving them high efficiency and low maintenance and good torque, especially in e-scooters and lightweight EVs. We'll see the performance or like working principles, how the brushless DC motor will work. See, there are the components called Hall sensor, electronic controller, stator, and these are the windings, and this is the rotor. This is the rotor, and these are the windings, stator windings. See, power from battery. First, we'll give the DC supply, DC supply to the BLDC motor. And power from battery means the battery supplies electrical power to the BLDC motor controller. Through the controller, which converts the DC into timed current pulses, the motor coils. It switches stator winding current electronically without no brushes. Rotor position sensing means there are the sensor like Hall sensors. They can sense or back EMF feedback tell the control where the rotor is. Through the Hall sensor, they detect the where the rotor is present and they give the back EMF. Magnetic interaction like energy in the right stator windings creates a rotating magnetic field and that pulls the rotor magnets making the rotor turn. Continuous rotation like the controller keeps switching the coils in sequence based on the rotor position so the motor spins continuously and smoothly. In simply we can say the working of the brushless DC motor means the will first will give the supplied DC electrical power to the BLDC motor. and that through the controller it converts into DC into limited time current pulsars and switches the stator winding current without no pressures. And the through the Hall sensor they detect the where the rotor is the present, and through where once we detect the rotor is where the rotor is present through the stator windings it creates a strong magnetic field and pulls the through the stator winding it creates a strong magnetic field and pulls the rotor magnetics to the rotor drum through the controller keep when the controller keeps switching the coil sequence based and the motor continuously runs and smoothly. So this is about the brushless DC motor definition and the working. Now we'll see about the permanent magnet synchronous motor drive. The will shortly we can call as the PMSMS. Like permanent PMSMS means permanent magnet synchronous motor drive. These are using these drives are used in permanent magnets in the rotor. They are compactly very efficient and very high power density. These are used in modern electrical cars, like a present electrical vehicles only. The working is the DC from battery or inverter. Like first we'll take the three-phase AC supply means we'll use the supply DC supply the through the inverter same as the brushless motor only. We'll give the DC supply. The inverter converts the three-phase AC power of the motor, and through the sensor we can decode the where the rotor magnets are. The inverter sends AC current to the stator windings to create a strong rotating magnetic field. The permanent magnets on the rotor flow this rotating field, pulling the rotor turning synchronous. The controller adjusts the frequency and amplitude of the AC current to motor speed and torque smoothly. Like in shortly, we can say that first we'll give the DC supply to the first we'll give the DC supply to the EV battery, and through the inverter which converts the DC supply to the three-phase AC supply to the motor. And through the sensor, we can detect the where the motor is present, where the rotor magnets are present. Through the rotor magnets, we can create a strong, sorry, an inverter sends a AC current signal to the stator windings. To the stator windings, we can create a strong rotating magnetic field. Through the field interaction, the permanent magnetic needles are rotating. We can rotate the magnet. We can rotate the rotor in synchronous speed. When the controller adjusts the frequency and amplitude, the AC to control motor speed and torque smoothly. In shortly, we can say that battery through first will in battery inverter creates AC, stator makes the rotating magnetic field, and afterward rotor flows. The motion will be produced. Battery to inverter creates AC. Here we'll use the DC supply. It will create the AC supply through the inverter. Through the when we'll use the AC supply, stator makes rotating field. The rotor flows and motion will be produced. AC induction motors type. These are the motors on electromagnetic induction to operate. They are the best, reliable, and capable of high torque, and they have been used in vehicles like early Tesla models. These AC induction motors drives are used in present generation in electrical vehicles only. The working with these are the AC induction drives. Working will be AC supply from the inverter, same as the brushless DC motor and PMSM motor. The through the battery the DC supply will use, and the inverter can convert the DC supply to into three-phase AC supply. And the three-phase AC supply, the inverter sends the signal three-phase AC supply to the stator windings and create a rotating magnetic field in a stator. And through rotating magnetic field, the rotating magnetic field cuts into the rotor conductors and inducing electrical currents. This is called only induction. And the rotor produces a magnetic field. The motor will run constantly with smoothly. The rotor shaft rotates. The through gates or coupling, the rotation will be delivered to the vehicles. through the when the motion will be produced through the gates, the rotation will deliver to the vehicles and vehicle moves smoothly. Switch reluctance motors drive. This is also switch reluctance motors drive. SRMS have simple rugged construction like this. This is a 6 by 4 design, like six poles and sorry, 6 poles and four. These are the phase windings. This is the six four po- four four pole rotor and a 6 pole stator. There are six stator and 4 pole rotors are there. The rotor and stator, the working will be the rotor and stator. Same. This is some of the different through based compared to above. The stator has a windings and the rotor has no windings. Only magnet, just steel poles that perfect to align where magnetic reluctance is lowest. Through the sensor will indicate the way the rotor position will be, and the controller knows the way the switch stator phases are there. Through this, the stator phase windings are energized by the drive. They create a magnetic field and pulls the rotor out back. When the rotor nears alignment with the stator pole, the controller turns the turn off winding to the next one in sequence. So that the continuous rotation will be occurs to producing continuous rotation and torque, the vehicle will move smoothly. In conclusion, electric drives are the core technology that enables electric vehicles to run efficiently and cleanly. They convert electrical energy from the they convert electrical energy from the battery to the mechanical motion to run the vehicle smoothly, and we control the speed, torque, and the direction of a electrical vehicle without any disturbances. One of the advanced electric drives not only enhances driving performance, they reduces the maintenance cost, but also supports zero tailpipe emissions and improve energy use, making EVs a key part of the transition to sustainable transportation. As the technology continues to advance with better motors, inverters, and control systems, the electric drive system will further boost EV range, performance through and environmental benefits. Thank you.